Hello guys, I'm Brandon, and this is how to solve problem number 7 for Physics BAP, Chapter 5. So, a sledge loaded with bricks has a total mass of 18 kilograms and is pulled at constant speed by a rope inclined at 20 degrees above the horizontal. The sledge moves a distance of 20 meters on a horizontal surface. The coefficient of kinetic friction between the sledge and the surface is 0.500. So A, what is the tension in the rope? B, how much work is done by the rope on the sledge? And C, what is the mechanical energy lost due to friction? Let's get started. Alright, the first part of every single physics problem is drawing a picture. So let's do that. I'll start over here. This is a sledge, and here are the bricks on it. Yeah, there we go. And that's gonna be 18 kilograms. There is a rope like that, pulling in, of course, that direction, and that is 20 degrees above the horizontal. And also, we know that the displacement of the sled is going to be 20 meters. Alright, so we have our picture, and then I drew in the free body diagram. Of course, weight, as always, is going to be pushing down. Weight equals mg. Going up is the normal force. Going back against the tension is the friction, and then tension in the rope. And again, our rope is 20 degrees above the horizontal, and the coefficient of friction, mu, is going to be 0.500. I'd like to redraw this triangle for you. I'll put it right down here. Alright, so there's the triangle, 20 degrees, and then of course, this is our tension up here. Now the sine of this is going to be over here. So that's going to be t times the sine of 20 degrees. And then down here is going to be t times the cosine of 20 degrees. Alright, so letter A is going to be solving for that tension right there. To do that, we need to sum up our forces. So here we go. The sum of all forces in the y direction is going to equal the tension times sine of 20 degrees. That's what we got right over here. Plus the normal force minus the weight. And I'm going to write weight as mg because over here weight equals mg. Now that's all going to equal ma, mass, times acceleration. However, it is not at all going up and down. It is not accelerating in the y direction. So that a can cross out, and we can make that 0. Now let's work on rewriting that equation. So we're trying to solve for this n over here. So, lowercase, n for normal force equals mass times gravity, because that when that goes on to the other side, that becomes a positive, minus t sine of 20 degrees. Now let's do that in the x direction. So the sum of all forces in the x direction equals t times the cosine of 20 degrees. That cosine of 20 degrees here, of course, that's along the x-axis. So t times the cosine of 20 degrees minus friction, because remember, friction is acting in this direction. You can write this Fr. I will be writing this as mu normal force equals ma. Now before, this became 0 because it was not going in the y direction. Here, they said it was being pulled at a constant speed, so this acceleration will also go to 0, making that side 0. So let's rewrite this equation. Again, I'm going to solve for that normal force. This one's going to be a little bit more tricky, but that's why it's an AP class. So normal force equals, I'm sorry, not F, the tension times the cosine of 20 degrees over the coefficient of friction, mu. Because both of these equations equal n, they equal each other. So mg minus tension sine of 20 degrees equals tension times cosine of 20 degrees over mu. So I'm going to rewrite this equation to solve for that t. T equals mu times mg over mu sine of 20 degrees plus the cosine of 20 degrees. Now we have solved our equation for t. We can plug in our givens and get an answer for that tension. So tension equals mu. Mu was given to us as 0.500, no units, times weight, mass times gravity. Mass is 18 kilograms given to us. Gravity is something we all know, 9.8 meters per second squared. And then that's all over mu, again, 0.500, times the sine of 20 degrees, plus the cosine of 20 degrees. So after doing all that math, you should come out with 79.4 newtons. This is in newtons because that is a form of tension. So 79.4 newtons is the answer for problem letter A on number 7. And now we are going to solve part B of problem number 7. Part B reads, how much work is done by the rope on the sledge? So for this we need our work equation. Work equals force times delta x times the cosine of theta. Well, we found that force. We found that force in the last answer. So work equals 79.4 newtons times delta x we know is 20 meters times the cosine of 20 degrees, because 20 degrees was our angle in our triangle. Doing all of this will get you 1492.23 joules. So the book answer actually puts this in kilojoules. So how we do that is 1.49 kilojoules. We will be solving letter C. Letter C reads, what is the mechanical energy lost due to friction? So the way we can write this as F of E equals the force times the cosine of theta. Again, F of E equals that force. We know that force. We got that in a last problem. That is 79.4 newtons times the cosine of 20 degrees. F of E is going to equal 74.6 newtons. Now that's just the force of the energy, but we need the work. So work equals F times the cosine of theta, which we just did up here. So we know that that's going to equal 74.6 newtons. Then we need to multiply that. We need to multiply that by the cosine of 180 degrees, because friction is going in that direction, and so far we've solved it in that direction. And again, we're looking for it on friction. So times that, and then we have to multiply 20 meters as our delta x. In the end of this, you should get negative 14.92 joules. You can, not 14.92, negative 1492.23 joules. That can be rewritten as negative 1.492 kilojoules, or negative 1.492 times 10 to the third joules. Now that is the force of friction, and that makes sense because we found out that in letter B, let me zoom in on that, we found out in letter B that the force going that way was 1.49 times 10 to the 3, so it would only make sense that the force going in the opposite direction is negative. So, I hope this helped you out. Good luck.